What am I looking for? Okay. All right. Today we're doing RPC framework. I've mostly figured out how I'm gonna do it, or I've mostly done it. Now it's just cleaning up the APIs, I think. And we'll be smooth sailing. Oh, I'm winning, son. I'm winning the game. Now, all yesterday I tried to write an RPC framework, and I think I got it pretty much working, and I ported over the game to it, but the interface was really bad. So now I'm working on cleaning up the interface, make a little bit more like well defined, and yeah. But it works pretty well. I'm happy with it. Very happy. How are you doing, Doro? Network stuff time? Yeah. Oh, this has been a massive re-networking of everything. Imagine using generics. You don't like generics? I mean, yeah, I'm using generics a lot of places here. I wish they made, I don't know how much slower, I don't know how much faster it would be if they did monomorphization, but I can't type brackets because I'm a Go programmer. What do you mean? What about arrays? It has been a while, Emily. Welcome to the stream. Welcome back. We're glad to have you. All right, let's run this. Here's gonna be my strategy though. You basically define your RPC service as a struct, and then inside of that you define your APIs that you're gonna have. Good morning, Mother Neuter. Good morning, JJ or Jomi. Gosh, it is early for me. But you basically build a struct. You set all of the handlers you're gonna have, and then from that, on one side you can generate calls. This is like the definition of the service. On one side you can generate calls, like this gives you a call that you can do, and then on the other side you can register handlers for it. Unforgivable unit, I know. Also, your guys' names start with the same letter, so it's basically the same word to me. Basically, is the same word. It's not the exact same word, but it's pretty similar. No, you're right. You can deduct it from my pay. The board can, or maybe the board can find a more fitting punishment. I'll start calling you undefined. J-O-me. I like that. Starts with a U. I was trying to think of a word that's like a good positive thing that starts with a U, but I couldn't come up with one. So I guess you have to stick with undefined. All right. Unemployed, there we go. Okay. Great. Perfect. That one does fit though. So it fits in more than one way, unfortunately. Or maybe fortunately. I don't have to go to work today, so I asked for it. Yeah, I guess I did. I blame myself on this count. But yeah, I'm happy with this. Because before it was very dynamic. Like I was passing in like, I don't know, I was passing in like an interface. And it was just kind of confusing. So, but we're using a lot of reflection, which I'm not super happy about. I wish there was better static typing stuff or better compile time utilities in Go sometimes, but what can you do? Sometimes you just have to suffer. Sometimes you just have to suffer. Okay. What's up, Barton? Use a different language? Oh no, I can't do that. There was a time where I was like, maybe I should switch to Rust or something. Because Rust is a good language for, Rust lets you like do whatever you want, basically. Switch to Swift. Maybe I'll have to have a Swift day. I do think Rust is a good language. I don't know about that. Oh, like you're talking about like borrow checker stuff? Well, that's why you have unsafe. Yeah, I guess there are a lot of times in Rust where I was like, this seems like it's very valid. And then it gets a bit noisy over time. Oh, Rust does? Yeah, I'm curious what people's experiences with Rust when they've had it for a long time. Because I feel like some people are like, oh, I love it. And some people are like, it's kind of a pain. If a language has unsafe, you can do anything. Yeah, I almost used unsafe in this package, but decided not to. Like I like the borrow checker utility of Rust. I don't know. There's some things that are like, I want to use Go, but I want this feature from Rust sometimes. It's a good language, but I don't want to use it for everything. Yeah. Like what yeah, I'm generally happy with Go. I'm switching my app over from Firebase to my own Rust backend right now. In my free time, it's going S so far. Oh, gotcha. Strong typing is nice, especially enums. Yeah, Go has like pretty strong. Like Go is a strongly typed language. I'd consider it. It doesn't have enums, which enum like it's weird because enums would only be nice for me for like serialization. I don't really. I wouldn't really use them that often because you can use interfaces for effectively the same sort of thing. When you serialize stuff, like the enum is like a very like common pattern because you always have like you would do like enum, like message 1, message 2, message 3. So this would be nice to have an enum for. Because then whenever you do like my variable is set to some enum or whatever, then you're guaranteed to it's only going to be one of these, you know? So you can kind of handle it on the outset. But I just use interfaces and it's a little bit slower, but what's up, Jen? I can't miss Swift and Rust enums, yeah. Yeah, some people love them. There's very rare situations where I'm like coding something that's not serialization and I think, oh, an enum would be nice here. But maybe I haven't used enums enough to know. All right, back to reflection. I really want Rust enums in another language, like the matching part of it. What's that language looked at? V had matches. If you use them, you'll know what you miss. Yeah, Yeah, maybe that's true. Maybe it's like this beautiful tool. Like it's the Go equivalent would be to have like a type switch, right? VLang, let's go. Yeah, last stream we watched a video about it. It was an interesting video. There's a lot of things in VLang which I was like, oh, that's kind of nice. Or no, what I thought was, oh, that's an issue I have in like that's an issue I'm actively having in Go. So it'd be nice to have like a solution to that. I've only seen such a Union Swift and Rust. Yeah. VLang had match statements too. But Go, you have type switches and you have the any interface, so you just use that, and it's basically an enum, except you don't have a you have to make sure you handle all the cases, and if you don't handle a case, then just a bug. There's no compile check for that. You don't have the advanced match statements though, like the what's it called? Like there's like Rust lets you do like weird match statements, right? I think you can't do that in Go. Suffer with me? Yeah, pattern matching. There we go. I'm only halfway into my first coffee, so my brain's still warming up. We're not firing up. We're only on one cylinder right now. About to get to 2. What's up, Dracula? I don't think I've ever done OCaml before, but you know. Did I call it this? No, I didn't. Cat's ain't active too. You're up really early. Yeah, this is I've streamed this before. Oh, here comes the cat. They just go outside in the morning because they're locked indoors all day. Oh, you. Can you guys see my cat? Oh. I need to lower my camera. No? Okay. Like a desk cam. I need to get like a little stand for my camera or something. Or if I have to turn my light on. Oh, I know. They're getting massive. Let me turn my light on because I feel like it's very dark on one side. Oh. Make it more mysterious? Yeah. I should wear a mask. Yeah, I feel like it's weird to have my camera up this high. I kind of want to like to be like more eye level, maybe a little bit higher, but I feel like it's like looking down at me. You guys are just looking down on me. I mean, at me. All right. Let's get this thing working. Aren't you used to that already? I am actually used to it, yeah. It's like us checking on your cubicle. Yeah. You guys are just standing over my, like it's like there's a cubicle wall right up there and you guys are just looking over it. Like that one TV show, Tool Time. Or no. What was it called? It was a show about a guy who had a show. And the show inside of the show is called Tool Time. I can't remember what the outer show was called though, or like the main show was called. We'll do this. Show, yeah, it was a showception for sure. But okay. Actually, I really want this to be a little bit more passed through. I guess it's okay to reuse this type though. I'll just start putting the new data inside of it. I want to use this as the index. Let me think here. Yeah, I think that works. Then I'll do service definition to get the inner stuff. Sorry, I'm just trying to think through this, but it's hard. It's like kind of hard to explain. Oh, are you? Nice. Do you like it so far? Like, what's your overall thoughts? Do you feel like it's more comfortable? I think the thumb buttons are the biggest game changer. The ortholinear part, I'm kind of like about, and then this is starting to look like Java code. Yeah. Too many mentions of the word service. Yeah. I just don't really have a good. I don't have a good term for it, other than service. I don't think there's anything necessarily wrong with like service-oriented architectures, though. But so that's kind of how I like. That's how I'm thinking about it. I wish I had a better way to think about it. Service factory, yeah. I have used the word factory before. The first day I used the keyboard was the first time my pinkies didn't hurt after a working day. It's definitely better. Nice. Yeah, the thumb is definitely a better key for that stuff, I think. I still use my pinky for control, but it's just right here, so it's, or you guys can't see, but abstract service factory. That's what we really need. Okay. Or let's do this. Let's just kind of copy this code over. Yeah, there are a lot of service defs. In combination with light switches. Oh, with light switches. When you said light switches, I thought you meant like RGB. I was like, why does that help you with your fingers? I gotcha. Are they really that light? Do you feel like do you feel like you typo things because it's too easy to press? When I use the numpad from the other keyboard at work, it feels like I have to smash the keys to be able to push them. Oh, really? Dang. You gotta do some finger curls. Work out your fingers. Do some rock climbing, then you'll get strong fingers. That'll make you a man. That'll make a man out of you. I'm just kidding. I don't know why I'm using my mouse here. You got the lightest switches. 30 gram operating power. Yeah, I have no idea. What are browns? Yeah, I want to do this. I can actually push this up into this. Let's just call it that. Resp. Oh man, I cannot remember how to pronounce your name again. But good morning. Josue? Or no, it's Josue. There we go. I remembered. Third game was crazy. Yeah. I had the DJ part helped me though. Third game was crazy. I thought 45 was extremely light. Yeah. For Gatoron. I really got the lightest that exist. Brown is 40. 30 to 40 doesn't seem that much. It's actually 38. That seems pretty close. I guess maybe you feel it a lot when it probably gets like exponentially difficult. Rec type. This is just going to be, or we can just do, I'll do it over here. Actually, I don't have to do this at all, do I? Oh wait, but this needs to be an interface. This has to be any. She like try to lick my ear. Wait, what are browns? Now I have to Google it. This is just too much fake news from Jomi. Actuation force. 55. Dang, so yours is almost half as light as mine. That means I'm twice as strong as you. Probably. At least. You know? I'm looking at the switch tester. Do you feel a big difference pressing the different ones? Not a chance. Oh, get out of here, Jomi. Oh, there's a big chance. All right. There's a big difference between keys. Don't bite my cables. So I need to first cast this to an interface. Then I can call I need to have like a type switch. See, Joe, thanks for stopping in. Good luck with all of your work. What a weird cat. These cats are attention hogs for sure. Okay. I need the function for Hope she heard something. I need the function for type. Oh, that's interesting. But panics if the type's kind is not one of the sized or unsized. Or sized or unsigned int? Okay. That's like implements. Implements reports whether assignable to, convertible to. I guess I can just cast it. Wait. I'm sure that there's some way. Or maybe what we do is this. Well, it's going to be field dot. We have to call that, but it's not field that we're going to call it on. It's going to be something different. We need to first cast it to some type, some interface. I've never written an interface like this where I do type interface and then type a thing in the middle. That's weird. Field, struct field. Oh, this is kind of cool. I can add tags to it too. So I could also add some metadata on that for my RPC calls. That's kind of cool. Anonymous. Okay. I'm trying to think because I have a struct field here. Oh, but I need to make one. Let's go to the test. RPC test. What's up, arcades? Arcados? How you doing today? Welcome to the stream. Oh. Where did I put this struct? Oh, this is the wrong file. All right, there we go. What was the objective today? Well, so I'm trying to rewrite my networking architecture so that it uses RPCs instead of just messages. So the RPC framework will work with both messages and RPCs. And the main difference of what I'm calling an RPC is just that RPCs will block until something gets sent back from the call. Something like you have here we can do a little diagram. Oh, this was last time, I guess. I'm just gonna have because I always go diagonally right, so I'm just have a billion diagrams and they're just gonna go down this way. It'll be a path. So before my interface looked like this. Like this is the duration of a connection. And the client would send messages to the server and the server would kind of respond independently. And this works really good for like update type messages. Like if there's a status update that's like, oh, this entity moved from here to here, then that's like an easy thing to just send as a message. There's no real like, there's no like back and forth on it. But then if you look at like the login system, this is where like I mostly would want RPCs. I basically want I want to send a message to the server, but in my thread, like this isn't a thread. In my thread, I want to block until I receive a response for it. So like I log in, and this is like the login response. So I basically just want my thread to block and then also hook back the response from the server. So I basically need both of these situations. And I also want it to happen bidirectionally so the server can also do the same sort of thing. It can make a request and get a response. And then it can also just, the client can send messages, the server can also send messages. It's like a message. And before, everything I had was architected like this, but it made it really hard to like track. I sent a login, but like, and I have to like kind of independently and arbitrarily wait for the response to happen. But this lets me like loop together the logic a little bit more tightly. Why RPC over just normal HTTP API to deliver ask response style information? I just don't really need, because I need to have this on the same, like an eyelash in my eye. I need to have this on the same like transport layer. Like I need to, when I open a socket from the client to the server, like I need to have an authentication thing that happens. I need to have like these request style things on that connection. Just because I want it to be like, I want it higher performance than what HTTP can deliver. I think HTTP is good, might be good for like lower or higher latency type information, but like I want this stuff to like be as quick as possible. So that's what we're doing today. But I basically have this working now. Like it's like another layer. It's another layer on top of messaging, right? You can send messages. Now I can send request responses. For my game, I'm using HTTP API to do anything that has to do with player data, etc. Like all of your player inputs go over an HTTP endpoint. I think that's to a player data center. Now the player data is sent to the game server. My game server is actually kind of dumb. It's just a headless state change that keeps track of world state. Gotcha. Okay. Yeah, like I guess when you authorize this connection though, you have to send some kind of data over, right? Like so you're saying you have two connections. You have your client and you have your server. HTTP is stateless. So when you do an HTTP connection, you have to send over your like credentials every time. But then for like your data pipe, which is the other connection you have, you also have to send your credentials over the first time. Well, at some point you have to send the credentials over. For anything that's more persistent, I'll just bypass the game server and ask the API, give me the list of star systems accessible from my current location. Oh, so you host game data on your server as an HTTP endpoint. Client gets issued a JWT when authenticating. So when you make like at some point though, when you make this connection, which is your like secondary, or maybe it's your primary connection, I don't know. This is the one that's like your, what do you call it? Player input is sent to the game server. What do you use for that? You don't use HTTP? You use something like a socket, right? Oh no, I'm out of coffee. I use a networking library in C#. Gotcha. Like at some point though, in this networking library, you have to say, here's my JWT. You have to say, I'm this JWT. You don't want to send it in one connection. You don't want to send it like, you have to send messages over this first of all, right? So you need messages. And then one of the messages you can send is your JWT. And that authenticates your sorry, my cat's doing weird stuff. That authenticates this connection to be like associated with this player. Right. So then like you could send that as a message, which is what I was doing previously, or you could send it as a request reply type thing. When my client joins the server, it authenticates through Steam, and that handshake allows me to send back a JWT which is stored and used for the API. Since both of them share credentials, they can verify and sign JWTs. Yeah, but like these are two separate connections. So like, how do you, hold on. Like maybe they do it behind the scenes for you. I don't know. But if you have two connections, you have to authenticate both of those connections. And HTTP is a stateless connection. So like you send your credentials over every single message. But then in a long-lived connection, you don't have to authenticate every single message. You can authenticate with one message and then keep it open for the duration. But then if like the authentication has kind of a request reply type pattern to it, you may as well use an RPC. But you can't authenticate this connection through this transport. Because then when this one gets open, you don't know that they're associated. I only use the long-lived connection for actual real-time uses, such as updating the world and handling inputs. Yeah, so, but like at the start of that connection, you have to say like, oh, this is like player Kai is like making this request. And then it's like, well, how do you know? Well, because he's gonna send over a JWT. I potentially can because JWTs are cryptographically verifiable, right? Yeah, I'm just saying you have to, like, you have to send, like, is this, sorry, is this a, I guess the first question is this a TLS or is this like a encrypted? Because like the first thing that's going to happen is they're going to exchange keys, right? There's going to be this whole like TLS authentication thing, right? And that's going to prevent you from having man-in-the-middle attacks for the rest of this connection. And then at the start of this, you should say like, here's JWT. And then you're going to send your JWT over. And then it's like, oh, now I know it's Kai. Like the JWT is what tells you that it's this person. But you can't, because this HTTPS is a different one. Like there's no association between these. If they send the JWT on this one, it doesn't imply that the JWT on this one's correct. You have to verify the JWT on both connections. But like all the RPC is the JWT. Yeah, I'm just saying you have to send the JWT on both of the connections. Either you send it in HTTP, you send it over with every single request, but in a long-lived socket, you can only send it over once. That's all I'm saying. I'm not saying that what you did was wrong or anything like that. Sock. I really need to get my drawing pad out. The same JWT can be used because you get your JWT from something else, right? And then you send your JWT over, which is your credentials. And then they can go off and verify. Like that's how it works. That's my understanding, at least. I had to get my drawing tablet every stream. Yeah, pretty much. I never think I'm gonna do a diagram, and then I always do. Yeah, but anyways, like because I'm gonna have this, because you have a socket connection too. I don't know what kind of protocols they let you do on top of that, but I'm trying to build out like my protocols that are built on top of my socket, basically. And one of the ones that I basically have two cases right now: messages, and I have RPCs. And an RPC is just like, it's a message that has a response and they get tied together. I'm just calling it an RPC. I think like, I don't know, my understanding is RPC is like a very vague term. So my implementation will be something like this. But the big difference is just that this has a response that gets tied to the original request. So that is what we're doing. RecDef is going to be, no, it's going to be field. Oh, RPC def. I need to get the RPC def somehow. Where are your cats? They went outside. What up, GIF? What is GIF? What do you mean? It's you. I'm GIF. I'm Jacob, or also known as Unit of Time. Oh, Jiffy, yeah. That's actually kind of what my name came from. What is it? It's like it's like a CPU tick is a Jiffy, right? Well, it's called no, it's not. I think it's called slightly something different. Oh, it's Jiffy. In computing a Jiffy was originally the time between two ticks in of the system timer interrupt. I never thought, because it's like, I also saw back in a Jiffy when I was typing this in, and I was like, oh, I never related those two things. Back in a Jiffy and Jiffy. But I knew they were both things. That was weird. Very weird. um, I basically need to do what? Type. So it's okay if I call you Jiff? Sure. You can call me whatever you like. Value of create returns a new value initialized to the concrete value stored in interface I. Well, I'm getting this type. So I need to do value of this. Field.type, and I'll do value of that to create one. That'll give me this type, and then I can do that dot. So basically initialize this, and then I do that dot request type. Okay. So it should be something like this, actually. Oh, I need to cast it to an interface, though. Wait, what is that value of? It gives me a value. When you look at the value functions, I changed this browser to be like larger text, but it makes it really hard to read everything. All the websites become really hard to read for me. It was all for you guys, though. I want you to know that. Indirect. Can interface. I guess I have to, I don't think I can go, I don't think I can really go back to this interface, can I? I think I have to. Reflection is such a pain sometimes. I should have made this stream title like doing reflection stuff. You see Linus got hacked? I hope you have two-factor auth. What do you get hacked on? Oh yeah, I saw it in Discord kind of, but other reflection, but Go's capabilities are really weak compared to other languages. Yeah, I haven't done reflection in many other languages other than Go. If Go had Veratic generics, I would probably like never have to use reflection. I guess I could do this. I can do explain variadic generics like I'm a dummy. Oh, it's just like you know, this is variadic or veratic. Spoiler, I am. Like this is it's just like this. How Go does it is this just I think like box. I don't know if you call it boxing, but this boxes it as kind of an array. Veratic generics would just be the same thing, but for generic things. Like if I wanted to have one with like, actually this is a good example. Like for example, I have a view 2. This is from my ECS library. I have a view 2 for when I want to view 2 components, A and B. And then if I do view 3, I have ABC. And I do view 4, I have ABCD. So a veratic one would just let me do like a list of generic arguments, and I could just operate on lists. I don't know how they would implement that, because they don't let you do, like this would be a veratic argument though. They don't let you do, what's it called though? They don't let you do function overloading. So you end up having to name them something different. I don't think they'll ever change this, so. But yeah, that's what it would be. That's how it would work. I have no idea how they would do it. I don't know how it's implemented. I just know that it's something that people have implemented. Okay, now we can do a type switch. We'll make this I don't remember the syntax for this. This is it, okay. We'll do case. Oh wait, I can't do this, can I? Internal make functions can have different parameters. I don't think I can type switch on a type. I think I have to get the concrete type out. I don't think I can type switch to get a interface. Or can you? We're about to find out. I don't know. No. Oh, that worked. I guess you can type switch on an interface. RPC definition. Wait a second. Oh, this is not what I wanted. Is that the whole point of a type switch? Well, I thought, for some reason, I thought type switches, you had to pull out the concrete type, not another interface type. I didn't realize you could have a type switch that pulled out another interface. I swear I've done this. This is what I want. Okay, perfect. I'm just gonna panic here. I need more coffee. That's what I need. Oh, here comes a cat. Hello, you. Am I sure about what? Oh. He just jumps up. He jumps up, like wants me to pet him for like 5 seconds and then runs off. He's just saying hello, I guess. All right. Give me the panic. Are you sure about that? No, I'm not. Well, I'll eventually. I threw it to do there. Come on. Little rascals. He's cute though. I tell you what. They're both cute. I don't know how they got so darn cute. All right, I'll be right back. I'm gonna go get some coffee, and yeah, we'll be back on it. Morning, JJ. All right. Coffee's brewing. I ate some peanuts. We're all set. Okay. I actually think this works. Go nuts, man. Oh, I went nuts. We're getting a little nutty out here. No big deal. I think that this will work. Where is this? Oh, I make the interface def. Do you write unit tests on some of those? For these functions? I do, this is actually a unit test right now. But I actually don't write unit tests as much as I probably should. Most of the time I'll write unit tests when I'm like kind of sure of what I'm doing and I just want to test it really quickly. Like I know what the API is already going to be and I just want to test that API. Like for example, math functions. Those are pretty straightforward most of the time. So it's like I want to check to make sure this matrix multiplication is correct. So I'm not going to like test that in my game. I'm just trying to unit test that runs in matrix multiplication and verify that it looks right for like a few cases. That's what I typically do. I can actually do this. I'm using my mouse a lot today. I don't know what it is. Wait, why did I do this? I just did this. All right. What did I call it? Define service? Cool. I think this is probably because of my message. Invalid type. Oh, never mind. I called my package Envoy, but I don't think I'm going to keep that. I think I'm going to change it to like RPC or something. The reason I called it something different was because I made a package in a first draft of this. I made a package called RPC. And I wasn't ready to delete it. And I couldn't change it. So, pretty silly. Pretty silly if you ask me. New service def. What is this called? No. Why did I do that? Oh, I changed the wrong one. Cool. Cool, that works. My objective is to have like some piece of data that I can spawn everything that I need out of it. Because you kind of have like on RPCs, you have like client side functions that need to be called to make the RPC. On the server side, you have handler type functions that need to be called when the service receives it. I'll definitely make a video about this to kind of go into detail of like how I built it, but it's pretty simple overall. I'm gonna do this here. That's kind of the server side. This is the client side. I don't like that they are I don't know how out of this I'm gonna pull the calls though. Like the RPC call, like client side call functions. Because they're in here. I guess it's strongly typed, but it's a service definition. I could just do this. And then this is what I can change. What did I call it? It will be I need to think, hold on. Okay, it'll be this. Interface def dot client dot client do thing dot get client. And that should be that call. So those are the difference. Like this is what the this is the reason. Just that I can have a strongly typed get function for a particular RPC function, rather than having to know what type the input and output is going to be on the client side. I feel like this didn't work. I feel like I usually see more messages. One? Oh yeah, client do thing one. I need to do client do thing response. Call Okay, 101, perfect. It adds 100 to it. That's what do thing does. Let me get my coffee, I'll be right back. Where streamer? He drinks like 8 cups during a 2-hour stream. Hey now. Hey now. Gotta ask about brew before judgment. These are hand grown in my garden. Hand grown coffee beans. Just kidding. I just buy them from the store. The problem with because I use an AeroPress. I don't know if you guys know what that is. Here, let me show you. Crock beans. This is an AeroPress. This is what I use to make my coffee in. And I let it steep. Like you pour it in, you put water in, and then I let it steep usually. They usually just like and then you plunge it down at the very end. It's kind of like a French press, but a little bit easier. Yeah. Big pushy boy. Make 500 milliliter coffee real good. Yeah, so this is what I use. And it makes good coffee. Just the problem is that you have to let it sit for like 3 minutes. So I figure I always come back. I might make it brews. I come back and then then I plunge it and get my coffee out. So that's why there's like 2 intermissions. So just half the number of times I go away, and that's how many coffees I drink. And here I thought beans only grow from plants. That's yeah, not real. Yeah, I do have a French press. I guess I could make a French press on my streaming days. That way I can just pour another mug. The problem is that French presses are like annoying to clean. But this thing's super easy to clean. Because it literally just pops out a little puck, like an espresso puck kind of. It just pops it out and it's completely clean basically. Okay, we just did this. Now we need to do the register side. One second. My phone's covered in cat hair. These cats are shedding like there's no tomorrow. But it's fine. Okay. Now what I can do is, before I make my client, I can pre-register my functions. This is gonna blow your guys' mind. This is probably so hard to follow. But so I apologize for that. There's gonna be nothing visual about today. I guess I can do a little diagram for you guys if you want, just to see like what the architecture is. Where's mine? There you are. There's this article I found. He actually pulled this diagram from by normal I mean standard lib. Yeah, I'm not using like, I understand that there's like proper RPC standards and stuff like that. I'm not really meaning that. And maybe this is good feedback for me not to use the word RPC in the future, but like I'm basically building my own RPC framework on top of my socket connection. But I'm not using gRPC or like standard lib RPCs. This is actually better than I could draw probably. But basically like mine's bidirectional, so like both can act as a server and both can act as a client. What could go wrong? Yeah, that's true. The problem with I guess, can you use RPC, gRPC over TCP? The problem I had with the RPC generated code is that it's just so hard to use. And I don't like how they serialize stuff. Like I have kind of specific serialization requirements. So I want to hand pack things sometimes to reduce on like bandwidth usage and things like that. So I don't know, maybe it's 2 days of wasted, but I'm pretty happy with how it turned out. So, but basically, you usually they code gen this like RPC stub, you know. Mine, I'm not using code generation. I'm using, well, kind of code generation, but I'm using generics for that. Or that's what I'm working on today. Basically, is to clean it up. Basically, when you do an RPC, I generate a random ID. I send it over to the server. The server receives it. They do their whole function handler processing. So you register a function handler, which basically does the work, you know. And there's like some deserialization and serialization stuff, obviously, on both sides. But I send it over with an ID, and the ID is an important part because I send that same ID back. And then the RPC caller associates the received ID with the transmitted ID. That way it can like correlate that this RPC called this function, if that makes sense. Because like it needs to be multiplexed over the connection with other packets and stuff like that. So so basically, like, this is the kind of interesting part, I guess, is you send the packet over with an ID, you wait till you receive a packet with the same exact ID, and I wait basically based off of a channel. So this is the like call function, where I basically have it's strongly typed too, so I have the request and the response as the type parameters. But yeah, so I basically construct a channel with this ID that I've generated, and then I marshal it, send it over the socket. This is the marshalling and sending over the socket part. And then I basically wait on the channel, or I time out after the call timeout period. But let's say that it succeeds on the server, or on, well, so I have a client thing that's like there's a singleton client basically. And whenever you do an RPC, it pushes that channel onto this active calls map. And this active calls map, you push the channel onto it with the associated ID. And then on the client side, because the client has to constantly wait for messages, right? So the client's constantly waiting for messages. Whenever he receives a response message, that means it needs to be associated with a caller RPC. And do you see that tail? These cats, I tell you what. Basically, so when the client receives a response, he needs to associate it with that ID that I mentioned before. Oops. So he basically looks up the same ID in the channel and pushes the response onto the channel, and that kind of like closes that hook of the do function, because the do function is waiting for the response on this channel, and then he cleans everything up. I actually might push this cleanup code to the other side though, but yeah, that's that's basically it. That's the architecture. The important part for me though is that I want to have one connection that I can multiplex RPCs and messages over. And so this is like the top level multiplexing part. And underneath it, I have packetization. So they are always sent in packets. And then you can kind of unmarshal. This will receive a packet basically. It'll read a packet into this data buffer. Then I unmarshal it. And then I determine based off of the message type what thing I need to do. So if I get a request, I need to call a handler. If I get a response, I need to correlate it back to a caller. And if I receive a message, I need to call a handler. And messages are like request handlers, except they don't have this like loop back part. So yeah. So that's that. But I ported my game over to it. The problem I was having though was that how I had defined the RPC structure wasn't very good. So like when I had to change something, I have to change it like 4 different places. So I didn't like that. I wanted to make it a little bit simpler. Way cleaner than what I was doing for this. I'd be deep into packing your byte arrays by now. Yeah. Well, I do want to make it more efficient because I have this. Here's another little tangent. Union. I mentioned this kind of at the start, but I think tagged unions are good for serialization. So I built like a union type where you basically create a union builder. I didn't call it a factory, notably. And you basically pack in all of the structs that could possibly be a part of that union. And then the union builder can basically construct a union, which is just this type. And all it really does is it basically maps the type you passed in to the serialization to an index type that gets used for the unmarshaller. So as long as you create the union the same on the client and the server, you'll have these IDs in the same order, and then you can decode them in the same order as well. It's been pretty stable. The only weird thing is that you can't you just have to make sure that the union builder gets the structs in the same order, which isn't a very good thing to guarantee. It's not very user friendly, but yeah. This is kind of my first foray into this multiplexing concept. And so I use this union builder in my RPC framework, but eventually I want to get it to a little bit more header with a length and then the data. I think I want to pack down the header a little bit because this does a lot of extra serializations, which isn't super efficient. There's more efficient ways to serialize this, I guess. That's the kind of point. Yeah. You sure you don't have many lines of binary.little Indian? Yeah, I think for some messages I might actually do that. I found this article. What was it? Is it on here? What's it called? Go unsafe struct serialization. Oh, okay. This guy wrote an article. He actually goes into like pretty good depth about different serialization methods. It's really, really long. Look how long this is. One of the and at the very end he has a graph of the different types of the performance and the, I think he has encoding size too. So I do use a binary serialization method. So it's a little bit more efficient than like flat buffers. So like flat buffers take 80, I guess, for his particular message type. Mine is a lot more complicated, so I expect my gains to be a little bit better than flat buffers. But also the serialization time of flat buffers is not as good as just using binary stuff. So like doing, well, I guess let me give you the quick overview. There's I guess there's binary little endian, binary big endian. Then you do the whole structure, which I think goes through the, this would go through the reflection package, and it would be like, oh, this struct is this type, let me serialize it that way. That's what mine currently uses. So it's really easy, it's really easy, but it's not as fast as doing like the no reflection way, which is what you're saying, where you just do binary little endian, like put uint32, put like, you know, into a big buffer. Eventually I want to optimize towards that, but I don't think it's worth it right now because that's a lot faster. So for some messages, it might make sense to do that, like position update messages and stuff, you know. Or I might take some inspiration from like how Rust does their serialization, and because they let you do what's it called? They like what I understood from Rust was that you did they would like generate the pattern of it. They would generate something that would like tell, well, I guess every struct has a list of things, and then it would generate some function which would do the serialization for you. So I might try to do something like that, and then hopefully get the gains of this performance without having to go through the reflection, but also not having to handwrite it every time. But I also did a little bit of benchmarking myself with the same sort of strategies, and I kind of came up with the same sort of data. But then one of the ways he like suggests is to do this unsafe cast way, which I don't think is a very good idea personally, but I get that it's very fast. But he basically just casts the he just takes a pointer to the data and just like, there you go, sends that over the network. But I think he has an error in his thing where he says that unsafe cast doesn't take a memory alloc for encoding, but binary serialization does. Where's binary serialization? Oh, no. Well, like the difference between unsafe cast is this one doesn't do a copy, but binary serialization does do a copy because it's literally copying the data to a buffer. This one doesn't. It just casts the buffer that already existed. We only go there if we're desperate. Yeah. The problem is it's not compatible with different CPU architectures. Like big endian, little endian architectures will fail. So then you have to have this function that's like, oh, if you're big endian, we're going to reverse all these things. And that sounds way harder to write than just doing a binary serialization. But it was very eye-opening how much faster the binary package is than doing the reflection way. But I'm okay with taking some overhead right now, just because I'm in like the development section of the game. What was I working on? Oh yeah, register functions. In my little project, I just have an updated interface that I pack all of my network updatables into. And I'll just implement a set position. I pack float 64s into int so I can binary pack it. Sorry, let me read that again. My little project, I have an updatable interface that I pack all my network updatables into. And then I'll just implement a set position. I pack float 64s into ints in binary packet. Interesting. Oh, I see what you're saying. So like in your game world side, updatable interface and have a slice of them. I think I understand. So kind of like that's the kind of encoding and decoding part of your game world. You basically have a function that lets you like decode a network update into the world. Yeah, I did, where is it? Floatnet test v, no, I wanna do test bench this. Yeah, I thought about doing something similar, like having them all implement an interface, kind of like how there's like binary Marshall and binary unmarshall. My target player is only 4, so looping them is not an issue. Yeah, that's one of the things that's like, that's where like serialization is very different depending on what you're trying to do. But like I basically kind of rewrote his benchmarks in my own way. This is a very small like Marshall. You can see the code if you want. But I wrote a lot of different ways. But basically, this is my union serializer, which is kind of like it does reflection, but it also adds that header on top. So it's the slowest, or actually, it's not the slowest. I guess this one's slower. Whole custom. I don't really remember, but the two target ones. This one's the like you write a manual serializer function and you call that. This one's you write a manual serializer function and you call it through an interface. So for example, I pass this in as an interface through this function that does the actual Marshall binary call. But it gets converted to an interface, which is probably the slow part. Like that's the only overhead from this one to this one, is the fact that this one gets converted to an interface first. So you can kind of see like how much slower that makes it. Oddly though, if you write a if you look at this one's serializing the same data set, except for it passes it into the whole struct. Wait a second. Oh, this one. Like if you write the how it should work is, right, you implement these two functions and that causes your data structure to implement an interface, and then when you pass it into the binary dot what is it? Yeah, binary.read and binary.write function. It should be just calling these Marshall binary, Marshall unbinary, but you can see that there's just massive overhead for that compared to this one. Like this, I would have expected this one to be as fast as this one. This one's calling the whole struct read and write function. This one's just calling it the same. It's calling the same function, but just through one interface, if that makes sense. But it's not calling binary read. It's just calling Marshall binary. But you pass in a binary marshaller, you know, which is the same thing as the other way. So it is kind of weird that these are different, even though they effectively are doing the exact same thing. But it's a little bit nitty gritty for sure. I think a lot of my performance is from serialization though, so, or a lot of my performance loss is from serialization rather. I think it's an interesting topic. But that is not our topic for today. That is not our topic for today. What is our topic? Oh yeah, we were doing register functions. So now I can do strongly typed registers as well. I just do TS, or no, I do interface do thing register ts.do thing, and that should be the equivalent of this function. But I register it on the interface definition, and then when where do I make the client? I have to make the client after this. This is kind of like connecting it, but so now I have an interface def. Envoy. I really don't like. I feel like it's kind of confusing still because it's this bidirectional RPC. You have like a server on both sides and you have a client on both sides, and so like I don't really know what to name these because they're both servers and they're both clients. But it's all in one connection. But the nice part about this is I think I could put this RPC framework on top of like any kind of netcon. That's my eventual goal. Right now I'm using my like internal NetSocket thing, but I think I can change that to use a netcon instead. I don't think that would be too hard. New client. I think what I have to do is, this does new server. I basically have to take the registered handlers and I need to push them into where's the register function? This builds the handler. So I need another interface. RPC handler. We'll do handler. Now this should implement that interface. So I do this kind of the same sort of thing I did over here, where I basically, wait a second. I need to get the, when I have this turned into a client or a server or whatever, I basically need a little bit more reflection where I go through the interface definition RPC. I go through the RPC and I look up the registered handler and then I just push that into the client basically. Or I hate doing this, but like, because I'm migrating the API over, it's hard to, I want to have both of them for a little bit. So I end up making like a 2 function, but it's not very clean. This is kind of it becomes a mess sometimes. This is why rewriting things is sometimes better. This one takes in a handler function. I think it's just, yeah, handler func. And then I can just do the, oh, the problem is this isn't typed at all. Time for a new project, yeah. RPC 2, RPC 3, RPC 4. I could do. Hey, what's up, Jose? Hey, of course. Oh, sorry, I said Jose again. See you, buddy. See you, Josue. There we go. I have to think about it. I don't think it's bad to rewrite projects. Some of my best projects have been rewrites of bad projects, you know? The hard part is RPC v2. I guess that is what people do, isn't it? I guess the handler, what it can do is this handle function. It can return this as well. I'll watch live later. Cool. Yeah, of course. You're more than welcome to. We just need to have the type associated with the request, because this is all keyed based off of the request type right now. It's actually writing from scratch. Yeah. Well, I end up copying a lot of stuff over, but I feel more confident in my changes because I know I have something to go back to. But there's hope we can do better. Yeah. I almost always do better the second time, or the third time, or maybe even the fifth time. I always do better. So we have register 2. Register 2. Right, I want to pass in the this will not be generically typed. We'll do this. I'm just gonna copy this stuff over for now. Then we just pass that in. Technically now this can be deleted. Actually, no, I can't. I'm just gonna leave it. I don't want to, because I'm gonna delete that function anyways. The handler's already been created. So we just store the handler. We basically look it up in the map and then store it. Okay. That's not so bad. Yeah, I'm gonna make it lowercase register. Okay, then when we do new server, we build the client and then we do client dot. We basically want to loop through all of the fields again. This is so like, whatever. It's so like, there's definitely some combination. There's some abstraction that I'm missing. I just can't think of what it is. There's some way I can share a lot of this code, but I don't know. Okay. What is it? Service. Yeah, d.service. So this will go back and get this piece of data. That'll be a field. This gives us an RPC def. Wait, we don't want to look for RPC def anymore though. We want to look for the other interface, the new one we just made. RPC handler. Now we have an RPC handler. Request type and handler. And then we just do client.register rec type handler. This can actually be a client function now. Perfect. So that should register the handler now, I think. Oops. How did I leave this? I register that function in the interface definition, and then when I create the server with this interface definition, it should automatically register it now. This also helps because now this forces all of the things specified in the interface def to be filled out, I think. Or what is it? Rec type. Oh, wait a second. What would I want to pass in? Any or... let's just have it return reflect.type. I think I can just do reflect. That. Interface def.do thing. Oh, it's service. So I'm registering a service handler for the do thing function. All right. Oh, because I changed the interface, but I didn't change this one. Let's see here. Yes, we're getting further along. Now we have errors. Just kidding. Handle request. Oh, I might be because I don't have. No, it should be just this. Because this one's not specified yet, the message handler. So that means I'm storing nil. Wait a second. We have a nil pointer happening here, which means handler's nil, which means the lookup of this handlers, what do we call register? I stored something here, but the handler was nil. Let's do that. Handler must not be nil. Okay. Or that's happening on this RPC def request response. So this function's returning nil. Oh, wait a second. Which means that the handler stored here is nil. Which means that something's wrong with there. I'm gonna comment these out. Oh, interface def.new service. That's fine if it takes a copy, right? Interface def. Oh, register is probably not a pointer type. Yeah. Okay. You're gonna play Diablo 4 this weekend open beta? Oh, is it open? Is it a free game? You have to buy it. I only ever played Diablo 3, I think. I wasn't like a huge ARPG fan. I played a little bit of Path of Exile. It's gonna be €70, but this. Oh, but open beta this weekend is free. Oh, cool. I wasn't planning to play it, but I don't know. Are you guys gonna play it? I probably won't play it, to be honest. It's not like exactly my kind of game, though. I do think that free QA labor, yeah, they pay me enough. No, I'm just kidding. I'm gonna try if servers are gonna work. Yeah, because I've seen some like streamers play it, and what is it called? Yeah, I saw like hour-long reconnects and stuff like that, which is just ridiculous. Client.register handler. RPC handler. I know I've got a bug somewhere. Interface def, service. Oh, am I getting the right thing out? Yeah, d.service. So this is registering all the service handlers. Oh, wait a second though. It's not doing it's making a new one based off of the field type. But what I actually want is I actually want the billion-dollar company can't even make servers work. Diablo 2 Resurrected had server problems for runs. Oh, really? It's not even really like, would you even consider it an MMO? Because you just do like small party dungeon raids, right? I guess maybe that's what the difference is, right? Diablo 4 is gonna have open maps. Some MMO-like features. Instances in the game. Gotcha, okay. I think that's an important feature in online game, in MMO type games. Like I may as well be playing COD otherwise, if everything's just gonna be instanced. Like, I don't know, the COD's a different game, I guess, but yeah, like it's like that thing. There's a difference between like playing with like 16 people and like playing with like like having 1,000 people in the world, you know? I don't know, I think it's interesting. I think it's more fun when you have a bunch of people. Yeah, it is crazy that they have so many server problems. Especially because it's, I guess they just have so many people. Like, I don't know how many people are playing, but I could see like that being a scalability problem. There's a funny meme of a guy playing Barbarian struggling, and then a maid shows up and clears the map in 1 second. Oh, really? Is a Barbarian really weak? I'm sure they'll balance it. So I don't want to do this. I want to do... All right, let's go let the... A bit weak, yeah. It's fun, though. I think it's cool that online games balance themselves. Like I'm glad that they do balance things at least a little bit. What's my favorite class? I don't know if I've played enough Diablo to even know. Barb didn't believe in magic, but after that day he did. I usually like playing like a ranger type classes though. Like that or like assassins. But like I like classes where it's not like I don't want to play a class where you just sit there and like don't do anything. Like I want to be actively like doing stuff. And I like classes that make you have to make a lot of decisions. But I also like, I think I prefer games that are like classless. Like RuneScape, you can just be whatever you want and you just build towards what you want. I think there's a lot of interesting decision making there. But so I don't like it when it's like, oh, I make some arbitrary decision at the beginning of my game, and then it's like, now I'm stuck as this forever. Support type builds have that. Struct field, type, tag. How do I get the value at this though? There's gotta be a way, right? Oh, it's probably value of. You probably do like value of. Yeah. Wait a second. Struct field. Wait a second. Value of append. All can address. No, can convert. Can interface. Field, okay. So I'm gonna take the value of the struct, and then I can get the field at a specific index. I need the type of the field. And I take the val, and then I do val. I don't do this. Well, I do this, but I do it a little bit differently. Field, val.field of I. We'll print out because we're lazy. Unless a heal junkie like me. Diablo 4 lets you reset skills for free. Can you? Oh, up to a specific level, I think. I'm gonna make a new guild. Don't worry. Nice. Can't wait to see the banner. Yeah, Diablo 4, like they definitely look like it. Definitely is a good looking game. It's just like not really my type of experience, I guess. I don't know. Value of. No, I'm gonna do maybe interface. Nope. Value.interface. Filed. Do you guys ever type a word so many times that you start to like think it looks weird? Sometimes I type a word like so frequently, I'm like, am I typing that wrong? I know it's like I know there's a term for this, but it's like when you see it so much that it starts to look weird. Field looks weird to me right now. All right, let's see here. Okay, so I guess that worked. So now we can just register handlers directly on the RPC function. I think all that's left now is to redo this same sort of thing for messages and then do a bunch of cleanup. I also want to make it so that I can pass in, it would be cool to build an interface and pass the entire interface in. Maybe I want to have it when I make the client, I need to do this for client as well. Hmm. I could probably put this into a function, I think. I could put all this code into a function, reuse it up here. This is a good starting point, I think. Today button? What do you mean by that? Oh, is today the first day you can play? I think the skill reset thing is a smart idea because I think it's stupid to make people get locked in if they like if you go down one path, you end up not liking it and then you're just stuck. I thought it was correct grammar for button, like you said. It was probably something that I don't know. I can't remember what I was talking about. About words when you write fast. No catch like any lost XP or cost. Yeah, maybe you could have like some amount of like some amount of XP lost or something like that. Like you spend something to respec. I'm fine with that, but it's just like when you have a decision that's like gonna put you into this new state that you can never go back from. I feel like that's always like a very hard thing to sell. Because if you ever do that to me, I'm gonna be like, I don't want to make this decision. Like now I have to go like read a billion wikis to figure out what I want to do here. Like as soon as there's no way back through that door, then it becomes a really big decision. And I think it's okay to have really big decisions, but they shouldn't be decisions that make you want to quit the game if you make the wrong one, you know? I guess I don't know. It's kind of it's definitely a balance though, right? I could make like a register handlers function. It would be what? Register handlers. Client.register handlers of d.service. I think that's all I need. I don't use sock anywhere. I don't use d.service. I don't use that anywhere. Cool. Another client function. Client. Cool. Now we can go back up to this. We can do the same thing. Whoops. These ones register the same. They register like the backwards handlers, if that makes sense. I think this should panic. Yeah. Okay. Handler must not be nil. So this means that it forces you to register all the handlers, which is a good thing. Because that'll guarantee that all your handlers are put in. Oh wait, I need to go to register. So here's my interface definition. Then I register all my handlers manually. Then I make the client. This one I don't need anymore. This call I can get the other way now. Do thing. Here's some great names. I don't like that I'm getting it, that I'm passing client into here though. Maybe I store the interface definition in the client when I do this. And then I can just do client dot. Let's do that. I can do like client dot call dot do thing dot get or something like that. Oh, but then now client has to be typed, which is okay, I think. I like this is a big decision. I think that this is okay. Now my entire definition is just handled. So now you have strongly typed clients. Oh yeah, I think I could have made this a lot simpler. No, it'll be pretty similar, I think. But now the client, because the client will be strongly typed. Yeah, I think this will work. Oh. This is Luna's contribution. That'll work. I'll do that later though. I think we've streamed long enough. I've done my board mandated hours. This will be the conclusion. Thanks everybody for stopping in. It was a good time. We got a good amount done. I'm happy with how it's turning out. We're unraveling the mystery. Unraveling. Thank you. Good to see you guys. Hope you guys have a good one. I'll see you next time.